Hello all. Today we are solving LeetCode problem number 1878. Get biggest three rhombus sums in a grid. So let me read out the question. So you are given an m cross n integer matrix which is called as grid. A rhombus sum is the sum of elements that are formed that form the border of regular rhombus shape in the grid. The rhombus must have shape of a square rotated to 45 degree with each of the corners centered in a grid cell. Below is an image of valid rhombus shape with corresponding colored cells that should be included in each rhombus sum. So basically here it is given. So it is a square but it is tilted 45 degrees. So it appears something like this. So anyways it is a square. Note that the rhombus can have area of 0 which is depicted by the purple. So each cell can be of area of 0 and this is a valid rhombus. So and return the biggest three distinct rhombus sum in the grid in descending order. So the task of this problem is we have to find or we have to calculate all the possible rhombus sum and return three the first three descending first three largest rhombus sum. rhombus Rhombus sum. So that is the task of this problem. So uh, you can see this example one where you can able to create the rhombus. So as given in the example, each cell is a rhombus of size 0. So if we are given a grid which is of m cross n size, example you have 3 cross 3, so which is 9, I mean total 9 cubes or 9 grid 9 9 elements, so 9 possible rhombus could be made. But along with that we have to test if any other rhombus which is of size 1, size 2, and it goes on, and this should be valid, could be made out of the rhombus, and calculate the sum and then append into the result and return the top three uh, area the rhombus sum in the descending order. So that is this ask of this problem. And you see the constraint, so it is still the n is still 50, which is 0 to 50. So in this case n square can be handled, and since we are using this grid we need to traverse, we can run this problem, we can come up with a solution which runs n square time complexity. So there is no need to worry about anything, we can directly jump into the problem. So here I'm going to explain with the help of example 1. So first, based on the question, we will use a result. Let me erase things. So yeah, so we will use a result which is a list which stores rhombus sum, and we will iterate from left to right in each row and append grid of ij. So which means we are adding the rhombus of 0 size. So based on this we will be here and we will be adding 3 into the list, so result will be 3. And now from here you have to check if a rhombus could be made of size 1. So this is size 0 and size 1, which means we have to check if a rhombus could be made of like this and this. But clearly we cannot make a rhombus because we missed this left, it is beyond the limit, and the top is also beyond the limit, but right is possible, but top and left is beyond the limit. So we cannot make a valid rhombus of size 1. So for size 0 it is valid, size 1 it is not valid, so size 2 cannot be made. So we stop here, we move to next element, which is this. So now we append 4 here. Again we check if this could be made. You can clearly see that left and right is there, but top is missing, so this cannot be made. Similarly here and here and here. So we will add 4, 5, 1 and 3. Clearly again 3 is repeating, so we can use a set to eliminate the repetition of the rhombus sum. So instead of list, this can be set. So now we have 3, 4, 5, 1, and there should not be any repeated 1. So now we are moving into the next row. This is 0, 1, 2, 3, 4, and 0, 1, 2, 3, 4. Let me change the color for the next row. So now we are here, and similarly we have to check if we could able to form a valid rhombus. Right is fine, top is fine, left is missing. So no, left, okay, this is fine, okay, this is missing. So we cannot create a valid rhombus out of it. So it is due to that reason we will again add 3 here, but 3 already exists in this set. So we move here again, from here left, right, and top is not there, so we will not be able to create one more rhombus here. So and 3 is the one and only one and only value here, so set 3 cannot be added, and similarly 4, 2, 3, this cannot be used to form a rhombus. So hence 4, 2 and 3 will be appended into the added into the set, and you can see 4, 2 is not there, so sorry, 4 is here, 2 is not there, so we add 2 here, 3 exists. So we continue. So end of row 1, when we are completing row 1, these are all the areas which we were able to form. So now here comes the main picture of this problem. So when we are coming to the second row, 0, 1, 2, ideally it is a third row, based on index it is a second row. So we are here. Similarly left is missing, so we will add only 20 to this. So let me update it by writing it down here. So 3, 4, 5, 1, 2 and 20 is added here, and we move here. So now we have to check if we could able to form a rhombus here. So this is the bottom, so you have to check left. Okay, so you have something here, and you have to check if you could able to this will be 3, left will be 3, and right will be 4, and top will be 4. So yes, you could able to create a rhombus here. So now if you are adding it the sum, so this is 30 and this is 4, left is 3 and right is 4, so which is 38 plus 3 is 41. So we add 41 here, and now you may get into a confusion that how could we able to form this rhombus, and how are we determining this and this, because we are here, that is we could able to access only the bottom, but top, left and right, how could we able to access it? So there, this is the place we have to think of it, because this is row 1 and the left and right is present in row 1, the bottom is in row 2. So clearly for finding this row 1 and the left and right, it is it's very clear that we will have we have to use size here, and we have to use the index actually, which is nothing but I and j, using which we are locating this particular bottom. So for left and right, this will be differ by size actually. So we are here, and which is I is equal to 2 and j is equal to 1. So now here this j will be 2 and here the j will be 0. So which means you have size is equal to 1. So j minus size and j plus size, using which you can determine the j part of this. But in terms of I also, this could be determined by the help of size 1, because you are at 2 and the I is at 1. So 2 minus 1 is equal to 1. So this will be determined by I minus size and j minus size. So using which you are determining this is for left, this is for right. So this is done, and looking at top, it is 0 and bottom is 2 for size equal to 1. Okay, so how could we relate it? Because 2 minus 2 is equal to 0. So that is how, using these two, we will be able to determine this particular index value. So how do we calculate this? How could we relate this? This could be related by I minus s, which is size 1 multiplied by 2. So using which you can calculate the I, and for this j remains the same. So for top, the I will be I minus s multiplied by 2 and j remains the same. So this is how you will determine this rhombus sum. So moving on to the next, you are here. So the rhombus formed will be something of this, so which is 200 plus 3 plus 2 plus 5, which is 210. So you add 210 here and you will continue this. It's the same, that is size 0 and size 1. And I forgot to say one more thing here. Since we are good with size 1, we have to check for size 2. So in terms of size 2, it is out of this left range, and top range is also out of the actual value. So it is due to that size 2 s is equal to 2, which is it is not possible at this point, this point, this point, and this point. So we will be repeating the same similar way of finding it out for size equal to 0, size equal to 1, and we will go on if it is within the limit. So for size 1, this is the way we calculate it. And when the size is increasing actually, uh, okay, let me come here. Let us come directly to this point. So this point is a very different point, because we are able to get a different size apart from size 1. So here in this example alone, clearly they have mentioned, from this point you have left here, right here, and top here. So which means you have a rhombus of size 2. So rhombus of size 2 could be formed here, and to calculate it, this is very different from size 1. Why? Because for size 1, there just the necessity to calculate the corner sum, or corner sum is just to calculate the left corner, right corner, top and bottom corner value. But in terms of other size example, size is equal to 2, we have this one and this one. So it is due to that reason you have to not exactly these two actually. You have this corner size is 2 and you have 20 here, so this part is remaining, which is 5. So you have to add this 5 to the actual sum which is being calculated already based on these corners using this particular formula, this one and this one and bottom regular. So now that you have to find this extra size based on the size, actually I mean extra sides based on the size of the rhombus. So for this, how do we locate it? So we can clearly again see here that this is in third row, this position, let me change the color, I think it's too clumsy here. So for this position, this is in third row and first column, right? So this is bottom left and bottom right. So this is in third row and first column. So based on that, we can say that we have I is equal to 3 and j is equal to 1. So which means, how do we relate these two things actually? So for this is in row, okay, this I is in, okay, so I is in this position, which is I is equal to 4. So not exactly this, I is equal to 4 and j is equal to 2, because from this only we have to get into 3 and 1. So clearly, based on this, yeah, so based on this we can use this the step function which starts with the 1. So we can iterate, because size is equal to 1, so we can iterate from 1 till size. Because of size being increased, you will have so many bottom left and bottom right sides which is to be found out and added into the result. So because of that, we iterate from 1 to size. So here size is equal to 2, so we start with 1 to 2, where 2 is non-inclusive, so we have 1. So now we have s is equal to 1 based on the loop for size equal to 2, right? So using which you can say that uh, I is equal to 4 and j is equal to 2. When subtracted by 1, you get I is equal to 3 and j is equal to 1. So bottom left can be written as grid of I minus step, which we get by the iteration, and j minus step. So this is done, and for bottom right, this sign should be changed to added. So grid of I minus step and j plus step, because this is in this particular place, which is nothing but this is 3 and 3, so we have to add 1 to it. So now for top left and top right, you can see this position as 1 1 and 1 3. So for j it is similar, which is minus step and plus step. So top left, top right. So grid of I and j, it is it is j minus step, and grid of I and j plus step. So here you can you this is the top position, so you can use this, which is nothing but I minus s multiplied by 2. And for this to get into the below level, you can subtract by step, because step is equal to 1 for the first iteration, and we stop at that position because of size is equal to 2, and hence we can say that clearly this position is subtracted by this. So using this, you can put it like I minus s multiplied by 2 minus step. no, my not plus step. Yeah, this should be plus added with step. So because of the next row, so similarly I minus s multiplied by 2 plus step. So this is how we do this, and we will be finding out all the rhombus value, and we get a set. We convert that into list and use sort function to sort it by reverse, and then we use slicing operation to get the top three. So we use a list of till 3, which will give us 0, 1 and 2 position values, and we return this as the output. So based on this, we are getting the rhombus, the valuable rhombus, or there's 3 rhombus actually from this question. So which forms 228, 228, 216 and 211 as the output. That is what we will be returning as the answer. So with this idea, let us go ahead and code this up. So we start with n, so length of grid, and m is equal to length of grid of 0. So I'll copy this grid because we have to use it to access the elements. So now that result is equal to set, so this is also done. So now we have to iterate. So for I in range till n, and for j in range till m. So first we will be adding the size 0 values into the result. So rhombus 0 result dot add, we add a grid of I and j, ij. So this is done. We start with s is equal to 1. So now we will be checking all the possible size till size with which we can form a rhombus within the limit. So now s is equal to 1, and for that particular condition, to determine the top and left and right limit, we are using this particular formula, which is we will be running the while loop till the limit. So while based on this observation which I have explained in the video, we have the top limit is said to be I minus s into 2. So this will be the top limit, and this is greater than or equal to 0, and j minus s is greater than or equal to 0, and j plus s is less than m. So top limit, this is the top, and this is left, and this is right. So now we will run this while loop till that much amount of time, and now we have to find the accumulated sum actually. So sum is equal to, we will have grid, the bottom will be grid of ij, grid of ij, and this will be added with grid of the top limit, which is I minus s multiplied by 2. So this is 1, and j remains the same. So now the left grid of yes, I minus s and j minus s. So this is the left limit, and grid of I minus s with j plus s. So this is the left right limit. So bottom, top, left and right. So now for size 1 only calculation of this is enough, but for other sizes, if we are having 2 3, it depends on the given grid size, we have to find the other size, which is the the not exactly the corners, instead the other sizes, which is the bottom left, bottom right, and those things. So we have to calculate by using, I mean, iterating till s times, which is starting from 1 till s times, so based on which we can find this the size, and apply it by checking the limit, and then finding the I mean locating the exact grid, and adding the values into the accumulated sum. So based on that, for step in range, we start from 1 till s times, so we run till s times, because s is not inclusive, so usually it is running up to s minus 1. Yes, since s is not inclusive, we are running till s. So accumulated sum increment by, so grid of I minus step and a grid of j minus step. So this determines the bottom left, then added with grid of, we will have I minus step and j plus step to determine the bottom right. So I minus step and j plus step. So now this is done, we have to calculate top left and top right. So again, grid of, we know the limit, right? So added with step, so which is nothing but I minus s multiplied by 2 and added with step. So and for j, it is j minus step. So this is top left, and for right, similar but j plus step. So I think better we can copy, and here it is, this is similar, I minus yes, and this is j plus step. Yes, so this is top right. So now this calculation is done, we will come out of the loop, and then we will add the result actually. So result dot add, we will add accumulated sum, and we will increment by 1. So now this is done, we have to come out of the loop. Yes, so we have to convert this into a list, and then we have to sort it based on the descending order, and then we have to return the top 3 elements. So result is equal to list of result, conversion is done, and result dot sort reverse is equal to true. Descending order sorting is done, and now return, since it is 3, we use slicing operation, so result till 3, so 0 1 2 will be returned. So that is it, and let me run it. There is an issue, so j plus s, j minus s, and greater than or equal to 0. Oops. Now it's working, let me submit it, and there you go. Thank you.